My name is Mohammad Tariq, and in this lecture, we will try to understand the code that we wrote in the last lecture. We have the insertion code for binary trees, and we will try to understand how this code is working and the pointers that we use, how these pointers are assisting us in creating a balanced binary tree. So I have few numbers here. As you can see, these are the random numbers. You can take any set of numbers, and I will use these numbers to create the binary tree. Okay, and these are the pointers that we used in the last lecture. So let's start the main method. We don't have the main method yet, so let's implement the main method. Public static void main, and create the object of the class equals to new binary search tree, and we have a binary search tree. And now these are the numbers, right? They are the same numbers, same setting as you can see on my right hand side, this one. Okay, these and these are same. Okay, so now I will run this code in debug mode so that you could understand. I will show you the values of these objects and these the members of this method, so that you know where our pointer is and how the code is implemented. So okay, so now let's take the first value. Let's take the first value, and the first value is 500. Okay, the first value is 500. Now I will run this code in debug mode, debug file. Okay, so now our pointer is here. I'm using F8 as a shortcut in the NetBeans for step over. Okay, so now I'm at the first line of the this code, of the insertion code. The first line is the ID is 500. As you can see, we have set the 500. Now we have 500, and the root is actually null right now. Okay, so this will be true, and new node is the root node, and now it will return. So the first operation is completed, the first task has been completed, and now we have a node with 500, and this is the root node, and root is pointing towards this node. Right, now the second value is 120. The second value is 120. So now let's highlight the second value here. We have this 120, the second value. Okay, so now we will first create a node with this ID with the value of 120. Right, now in root is equals to null. No, root is not null because we have the root node now. Now in this line, what we are doing is we are giving the reference of the root node to the current pointer. Right, so this is the current pointer. Now the current pointer is actually pointing towards the root node. Okay, and parent is equals to null. So parent is equals to null. Parent is equals to null. While true, now current, we are assigning the reference of current to the parent. Now this parent is also pointing to the current node, and the current node is pointing to the root node. So both are pointing right now towards the root node. Now the ID, what is ID? ID is 120. 120 is less than the current node. The current is 500. Okay, this is current node, and current node is pointing towards the 500. So is 120 less than 500? Yes, it is less than 500. So this condition is true. Now what we are saying is current dot left, whatever so we have two references here. Okay, so we have two references. As we know, every node has two references. These two references. This reference is also null, and this is also null. Both are null. So what we are saying is current dot left the reference of current dot left should be assigned to current. So it means that now this is pointing towards this one, the left hand side. Right, current is equals to null. Yes, this is equals to null. So what we will do is we are giving the reference of the new node to the parent dot left. Right, to the parent dot left. This is parent and this is left. This is parent node and this is the left reference. So what we are actually doing is we are assigning, or we are giving the reference of 120 here. Okay, we are giving the reference of 120 here. My drawing is not very good. Let me redraw this, okay, in a better and a clear way. 120. Okay, now return. We are returning. Now the next value is 50. The next value is 50. So the next value is we have is 50. Okay, so we are creating a new node with the 50. Okay, now current is again referencing towards the root node. It's referencing towards the root node. Parent is null. Parent is null. Parent is equals to current. It's actually here. So when it was null, it should be here, and then it will reference here. So now the next value is 50. Is 50 less than 500? Yes, it is less than 500. Now it is less than 500. The condition is true, and it will come within the block of this if. Okay, so current dot left. So whatever is the left, assign it to the current. So here it's coming. It will come here, right? Now the next is current is equals to null. No, it's not equals to null this time. This current is actually referencing towards a node. Okay, it's not null, so it's come back. It's going again. Now what it's saying is whatever is in the current, give that reference to the parent. So now the parent is also referencing to the current node. Okay, got it? The parent is also referencing to the current node according to this line. Now ID is what? ID is the same, 50, right? ID is 50. And now current dot data. What is current? Current is 120. So 50 is less than 120. Yes, it is less than 120. So it's the left hand side. Now again we have two references here. Okay, this is left hand side and this is right hand side, and both are null also. Okay, so current dot left. So now this value, this node is pointing towards this node. Sorry, towards this one. This is left hand side, right? So if this current is equals to null, yes, this node is null. If this node is null, parent dot left, this is parent and this is left hand side, and assign the reference to the left hand side. So now here we have something like this, and we have 50 here. Okay, this is n, and now we will return. Now the next value is 600. The next value is 600. So let me highlight 600 here. So we have the 600. Okay, now we just created the new node with the value 600, and now the current will reference to the root. So this current will now again reference here, and parent is equals to null, so it's null. Right now it's not referencing anyone, while true. Current, the parent is equals to current, so parent now referencing to the current node. Okay, now ID is what? ID is 600. ID is 600. ID is 600. And current dot data, what is current? Current is 500, right? Current is 500. Is 600 less than 500? No, it's not less than 500. So we will enter into the else code, right here. Now we came here. Now what we will see that if the right hand side node is null or not. So the current dot right, we will reference the current dot right is equals to current. Whatever is on the right hand side of the current pointer, we are giving that reference to the current itself. Now the current pointer is pointing towards the right hand side node. Is current is equals to null? Yet yes, it is equals to null. So what we will do, we will assign the new value to the parent dot right. Now this is parent and this is right node. This is parent and this is the right hand side node. So it's very simple. Now we'll create a new box, and this is 600. Okay, now we will return. Now the next value is 150. The next value is 150. So we will remove this, and the next value is 150, right? So we will create a new node. After creating a new node, root. Now its current will point towards the root node. It's pointing towards the root node, and parent is equals to null. So the parent is equals to null. Now current is giving its reference to the parent. So parent is again pointing towards the current node, current pointer. Sorry. Now ID is what? ID is 150. 150 is less than the current dot data, and the current is 500, right? So is 150 less than 500? Yes, it is less than 500. Okay, it is less than 500, so that's fine. Current dot left, let's assign the left reference to the current. So the current pointer is now pointing towards this one, towards the left hand side of the root. Now is this null? No, this is not null. This is not null. Go back. So now parent is equals to current. Current is pointing towards 120, so the parent will again point towards 120. Okay. Okay. ID is 150. Right. The current value is 150. And is the 150 less than 120? Means 150 less than 120? No, it's not less than 120. So we'll come into the else section. Here is the else section. Current dot right, whatever is the current dot right, let's assign that to the current. We are assigning this to the current, the right hand side of this node. Now we will see, is current is equals to null? Yes, it is equals to null. If it's equals to null, so parent dot right, so this is parent dot right, this is the right hand side node that assigns the reference to the right, whatever is in the new node. Okay, so what we will do, we will create a new node here, or is actually assigning, we are assigning the value, and it's 150, right? It's 150, and now we will return. Now the next value is 750. Next value is 750. We are creating a new node with the value 750. Okay. Now this again we know that will point towards the root node, and parent will point towards null, then point towards null. While true, then parent again points towards the root node. Okay. And now what is one? Now the next value. Sorry, let me highlight the current value now. Let me highlight the current value now. The current value is 750. Okay. Now 750 is 750 less than the current node, the current pointer. The current pointer is 500. 750 is less than 500. No, it's not less than 500. So we will come in the else section. So here we are in the else section. Current dot right. Let's assign current, whatever is in the current dot right. The current dot right is this one. Okay. So the current will point towards this node. The current pointer is pointing towards the 600 node. Is current is equals to null? No, current is not equals to null. So if it's not equals to null, we will go back. We will go back, come back here. Now assign parent whatever is in the current. So the parent pointer is now pointing towards the node 600. Now let's check again. Is this 750 is less than 600? Is less than current dot data? This is current. Is less than 600? No, 750 is not less than 600. Is greater than. So we'll come in the else section. In the else section, so again here we have two references, right hand side and left hand side, and these both are null. Okay. So current dot right, whatever is in the current dot right, it's pointing towards this, because we are referencing we're giving the reference of the right to the current. Now this current is this pointer, this current point is equals to null. Yes, it is equals to null. If it's equals to null, assign the new value to the parent dot right, right? To the parent dot right. So this is the parent and this is the right node, the right hand side reference. So what we will do is this section will have what? 750. Okay, 750. And now we will return. So now next is 640. So this is the way, this is the procedure and the code flow of the insertion operation. So I wanted to explain this. I thought when we wrote this code for the insertion, you might have missed something. You must have some confusion. So in this lecture, I focused on giving you the flow of the code to make you understand how the flow is working and how the pointers are helping us in creating a binary search tree. So I hope this will be helpful for you, and try to understand this code and try to write your own code. Don't just copy my code or any other's code. Try to understand and write your own code. Thank you.